Okay, here is the video tutorial for lesson 11.2. So quick warm up here, just to remind what we did last lesson. So mean, median, mode, and range. If you want to do them by hand, that is perfectly okay. On the next page, whoops, let's move that right in away. I actually typed out all the numbers just in case we want to do it the Desmos way. So the mean of A, I can do median as well. Whoops, I have to do it all lowercase though. I must remember to do that. And for mode, I just got to look which number appears the most. I can see there's three threes here, so 3 is the most common number. Range is biggest, take away smallest. So the biggest number is 9, and the smallest number is 2. So that would be 7. So it's head around to the nearest 10, so 5.1 would be good for that one. Median was 5. And the mode we saw was 3, it appeared 3 times. And the range was 9 take away 2, which should be 7. Let me just scroll down a little bit more. There we go. So just to confirm that we did answer those correctly. Today we're going to look at the box and whisker plot. It says here it's a special type of diagram showing quartiles 1, 2, and 3, where the data can be split into quarters. So this tends to focus more on how data is spread out and how close particular values are together. So one thing to notice on this straight away, the mean is not listed anywhere on here. The mode is not listed anywhere on here. Now, specifically, the median isn't mentioned, but quartile 2 is actually the median. So you can work that out. The range was the biggest value, take away the smallest value. So you can also work that out from here as well. So each of these parts of the picture represent 25% of the whole data value. And you can see here, actually, they did label quarter 2 as median this time. So this is the smallest value, the lowest value. That's then the 25% values. We then have our quarter 1, quarter 2, quarter 3, and a final value. So each of these is groups of 25%, 25, 25, 25, and 25. So you can read off values from here. So the minimum value, you can just read from the very left there, would be -1. Oh, sorry, +1. Whoops. No wonder it said mistake. Quarter 1 is the left-hand side of the box, which is 3. Median is the line inside the box, which is 4. The quartile 3 is the end of the box, so it's between 5 and 6. I'm going to hope that they were sensible and did 5.5. And the maximum value from the right of the box, you can see, is 8. So it's just a special type of graph that you can read from to get information out of. Explain why the right-hand side of the plot does not have a whisker on the right side. So yeah, this one, the last pictures we looked at, there was something on the right here. Now, the reason it doesn't is there's so many values for this last value here. So 75% of the values are this value here. But also, there are no values after this. So 100% of the values are also this same value. So a little bit of a strange picture there, but you can have something where the quartile 3 is the same as the highest value. And you can also have quarter 3 equaling the median as well. And we'll see some of those questions later. Skewed data. So if we look at this, we certainly won't notice this is not symmetrical. You can certainly see that this left whisker is a lot shorter than this right whisker. That means that we can see that the top 25% of data values are more spread out. You can also see that the second 25% of data values are more spread out than the third 25 as well. So by looking at how long these parts are, you can see how spread out the data actually is. This is an example of parallel box plots. So sometimes we have two data sets together and want to compare them. And pictorially, this is kind of much easier to do. So name 3 statistics that are the same for the both. Well, I can see that the smallest value, or the minimum value, is the same for both. Certainly the first quartile is not the same. The median I can see is the same as well. Quartile 3, the upper quartile, is the same, and clearly the maximum values aren't the same. So minimum value, median, and quartile 3 would be the same for this question. 2 that are different, that'll be the ones that we didn't talk about then. First quartile and first quartile, you can see are certainly not parallel to each other, and maximum value and maximum value. Which group has a larger range? So you can work it out by looking at the numbers. Like you can do 6 take away 1, which would give you 5. And for this one here, it would be 8 take away 1, which is 7. So clearly 7 is bigger than 5. So I would type in red for this one. But you can also see by looking at the picture, if you look from the end to the end of this, you can see that this is much shorter than what this one is as well. Now, there's also something called the interquartile range as well, which is the difference in the quartiles. So range is biggest, take away smallest. Interquartile range is the biggest quartile, take away the lowest quartile. So that's quartile 3, take away quartile 1. So looking at this, it looks like it's about 5.5, take away 2.5, which is 3. And for this one, it's 5.5, take away 3, which is 2.5. So the blue one is slightly bigger for this one. And not so obvious for this one, but if you look at the picture, this width here is supposed to be longer than this. I think you can just about tell that from this picture. Explore and observe. The graph demonstrates how a dot plot is related to the box plot. You can move the dots around. So each of these dots represents a number. So there's 2 1s here, 2 2s, a 3, 3 4s, and so on. And if you want to experiment with this, you can actually see how it actually changes the values. Notice sometimes by moving a dot, it doesn't actually change anything because we're only looking at that 0, 25, 50, 75, and 100% number. So any number that's in the middle won't actually change that, but numbers at the end certainly will. And if you change things in the middle as well, you'll notice things that change as well. So you can experiment with this as well. If you can put the values all in a long line as well, you can kind of see what that does as well. Or if you stack certain values up, you can see what that does too. So that might be worth a little experiment too. Don't move any of the blue points, move the red point, notice what happens. And same thing, nothing happens here because these are not the 75 or the 100% values. So it doesn't actually change. So when you look at a box plot, it doesn't tell you what individual values are, but it just tells you what those key values are at those quartiles. Create a data set in which the median has the same value as quartile 1. So basically this line would be the end of the box. So you can experiment a little bit. So clearly that's only changing the end, so that's not going to do anything. And perhaps if I only move a few, I might not notice any difference either. Oh, now notice by moving a few to the left, from the middle, that moved the middle box to the left as well. So perhaps what I need to do is just move a few more of these across. Let's see if that will actually do the trick. And you will notice that the line in the middle is gone, basically because it's the same as the left now. 25% values is the same as 50% of the values, which would be in this column here right now. You can do a similar thing with this one. I'll let you have a little play. And the same with this one too. There is a little example where you can practice putting the numbers in here and just making sure that you can see where these different things come from. So although there's 4 quartiles, you'd actually need 5 values. You've got the 0, 25, 50, 75, and 100. People often forget the 0 one, so you need 5 values ideally. So this looks like a typical kind of an SOL type question. They've given us a picture. They've told us what's going on here. Write down the median score. So basically it's knowing what we're looking for. So the line in the middle of the box, which is at 30, that would be our median. Highest score, so this is a scale of 1 here, so 40, that's 45, 46, 47, that looks like 48. Interquartile range was Q3 minus Q1, so 35 minus 19, which is 16. And it says Martin scored 35 marks. Oops, move that across. Martin scored 35 marks. What percentage of the class scored a lower mark than Martin? So 35 is that point here. And remember, this is the 3rd quartile. So how many scored lower than him? So this would be 75%, basically. 3/4 is 75%. Don't know if you need to put the percentage symbol there or not. I got a little smile, so it looks like I am good for this one. Which box on Liska shows 3/4 of the data were greater than -30? So that means I need 3 sections of the picture above -30. So here's -30. And here's my 3 sections. There's the median, there's quartile 1, so there's the median, there's quartile 2, and there's the highest value. Notice there's no part on the left of this. That just means it's going to be the same. So looks like C for me for this question. For this one here, I can only see 2 parts above, so it's not that one. This one has no parts above 30, negative 30, and neither does this one either. Might be argued that this question could technically be wrong as well, as there is no left tail on this value. Oh, there's the extreme value at the end. Okay, I just missed one thing for this. I was just about to say here, there's no tail on the end here, so actually 100% of values at the end. If we have these very extreme values, rather than joining them up, they would just put a dot here to represent this. So this would be the left whisker technically. Can you make a box and whisker plot that meets the following criteria, 3, 7, and 9? And you can try filling them in. Clearly, you would need a 3 and a 9 and all the numbers in between. Or those numbers have to be between that, otherwise this wouldn't work. And you might need numbers slightly closer to 9 if you want the middle number to be a 7 as well. Now, if you want to create your own box plot, then you can do this in Desmos as well. When we used to do this by hand, this can be really tedious. So this is a really good tool to do this. So you type out your set like we did before. So capital letter equals which numbers you're going to use. And then you type the word box plot, and then it'll do the drawing for you. It does say that you need to include, click on the magnifying glass. So let me show you what that actually looks like, just so you can see. So box plot, capital A. And then sometimes you can't see this. This one we can see just fine because it goes from 0 to 14, and so do our numbers. But if you click on the magnifying glass, then you can see it. And you can zoom in and zoom out just like you've done previously as well. Make it easier for you to read off values if you need to. And then from here, there's questions that we can try. So biologists are studying the weight of albacore tuna caught off the coast of Washington State. A sample of the tuna is taken and their weight in pounds are given below. What is the lower quartile and the upper quartile? So clearly, if we want to find these, we want to look at the box plot. So let's go to the next slide. I already typed these ones in. So I just need to be able to see the picture now. So let's have a look at the box plot for A. I'm going to click on the little zoom thing there. And I wanted quarter 1. I might have to zoom in a little bit for this one to see a little better. There we go. So quartile 1 looks like 22. Quartile 3 looks like 37. Let me just go back and check. There we go. So quartile 1 was 22. And the upper quartile was 37. And most of these questions now, it's just getting used to the typing into the data values, the terminology used when you want to draw these. And then there's some questions that you can go ahead and try yourself. I would think for small data sets, for ones like this, particularly when it says what is the minimum, I would take a quick run through. If you can see, like I can see fairly easily, this is 7. That's going to be a lot easier than having to create a list that says A equals, type in all those numbers, and then type in min A. So sometimes it's still better to do these questions by hand if you can. The longer the list gets, the more difficult that becomes. That does it for this video. Go ahead and try the rest of the few questions within the Desmos activity, and that's it for this lesson.